Example 5. Given function f, y equals 2x, and function g, y equals 4x minus 3, show that this is true. Okay, so it's very easy to do. Let us first start with writing down the functions. So y equals 2x, it's the function f, and the function g is the function y equals 4x minus 3. To work out this problem, I will need to find the inverse functions to those two functions. So let me start with finding the inverse of f. Okay, what is the inverse of f? It is obtained by replacing y by x and x by y, so interchanging the variables x and y. So I take the formula y equals 2x and interchange the variable and obtain x equals 2y. And now I express y by dividing by 2. Okay, dividing by 2, I get y equals x over 2. So the formula for the inverse of f is y equals x over 2. So I'll place it in a box. So this is the formula for the inverse of f. Now let's work out the formula for the inverse of g. So the inverse of g, again, I replace the I interchange the variables x and y. So I get x equals 4y minus 3 and try to express y from this equation. So I add 3 to get x plus 3 equals 4y, and now divide by 4 to get the answer, and the answer is going to be y equals x plus 3 over 4. And this is the function inverse of g. Again, let me place it into a box like that. So here we have the original two functions, again in boxed like that, and here are their inverses. Now, to do what we are asked to do, look at this expression here, or this equality. We have to rewrite it into a more convenient form. So we already know that this has to be understood as the inverse of the inverse of f of the inverse of g of x. And we ask whether or not this is equal to, and again replace this thing. Well, I will not replace it because I first have to find the composite function of these two functions. So let me do it. Let me find g combined with f like that, and the inverse. Sorry, not the inverse, just this function. So this function is a composite function of two functions. First we take f and then g. We read it from the right. So this is actually the function g of f of x. Okay, so let me try to find it using these formulae here for f and g. So this is actually g of, and instead of f of x, I write 2x. Okay, and now I can replace g of 2x by using the formula for g, but instead of x there, I will write 2x, which appears here. So it's 4 times, and instead of x, I use 2x minus 3. And this must be then 4 times 2 is 8, so it's 8x minus 3. So this function here, it's the composite function of g and f. So it's g of f of x, and this is the formula for that function. Now I need to find its inverse, which goes to this right-hand side. So what is the inverse of this function? Well, the inverse can be obtained by replacing y and x in the formula of the function. So this is the original formula of this function. And now if I replace those variables by each other, so it's x equals 8y minus 3, and express y, I should get the function that I need. So this is actually x plus 3 equals 8y, sorry, and now divide by 8 to get y equals x plus 3 over 8. So here on the right hand side, I should have the function x plus 3 over 8. The only problem now is to compose or combine these two functions using this and this result. So first, let me start with copying the inverse of f, and instead of the inverse of g of x, I write x plus 3 over 4, x plus 3 over 4. And I ask whether this is or not, or it isn't equal to x plus 3 over 8. Now, I will use the formula for f inverse of x, which is x divided by 2, but instead of x, I use this fraction here. So I have to divide this fraction by 2 if I want to find this formula. And if this fraction is divided by 2, it's like this. It's x plus 3 over 4 divided by 2. And I ask, is this the same as x plus 3 over 8? Well, of course it is. Division by 2 is identical to multiplication by 1/2, and therefore the left-hand side really is x plus 3 over 8, and it equals x plus 3 over 8. And this way we were able to prove this nice identity. So what is the meaning of this formula here? Look here at the right hand side. Here we are asked first to combine or compose functions f and g and then do the inverse. So if you combine or compose two functions, something is done by the first function f, and then something else is done further by way of function g. And now you want to take the inverse. If you want to take the inverse, you want to undo what has been done. And you have to undo it in the reverse order. So first undo what the function g has done, and then you should undo what the function f has done. And this is exactly what appears here on the left-hand side. First we undo what the function g has done, and then we undo what the function f has done. So you see the reverse order. Here we have first f, and as the second there is g, and here as first appears g, and then there is f.